All right, let's go ahead and get started. In terms of where we're at, my goal is to focus on lines, and lines are actually, you got this kind of introductory section of section 2.1, and lines really hit 2.2, and if I get through all that good stuff, then we'll move on into section 2.3, which is on circles. So again, we're beginning into the area of, well, number one, lines, and that's going to be hugely important. But then we're going to also look at some different types of what we call conic shapes. Circles, ellipses, parabolas, hyperbolas, so forth and so on. Look at the standard equations for those and stuff. So, all right. So let's go ahead and pick up where we left off last time. And just to remind you guys, the concept definition of a slope. The slope, by definition, is the rise over run. We talked a little bit before about that. Also, getting used to calculus and mathematical terminology, it is what we call the change in y over the change in x. But you'll notice in a symbol here, we got delta. Delta y over delta x. Delta in mathematics stands for the change. So get used to that terminology because you'll see it again. So slope is rise over run, or the change in y over the change in x, or by definition, the change in y would be y2 minus y1 divided by the change in x, x2 minus x1. And where we're going with this formula here is you will be given 2 points. A first point, notice a subscript x1, y1, and a second point, x2, y2. So to find the slope between 2 points, you do the change in y over the change in x, or y2 minus y1 over x2 minus x1. Now, the whole purpose of this is this. What does a slope of a line tell you? Pretty much tells you the direction that you are going. All right? And for right now, you guys are dealing in two-dimensional math, x's and y's. Later on, we'll do three-dimensional math, x, y's, and z coordinates, and then you get the idea of multi-dimensional math. But for classic math, we got x and y. So when the slope is positive, you have a slope greater than 0. That means that the slope is increasing. What is the slope increasing? When it comes to graphs, you always read a graph from left to right, from negative numbers over the positive numbers. You're running up the x-axis, basically, as you read a graph. You read it from left to right. And then we draw a little arrow going left to right here with little arrows, but you read the graph from left to right. So if I read it from left to right, you'll notice that the graph will be going up if the slope is positive. And if the slope is negative, that would be a decreasing slope, aka the line would be going down. And from left to right, you'll notice that it is going down. When you have a slope of 0, a very important concept, slope of 0, that means there is no change in y. So it's got to be 0 over a number to get 0. So there's no change in y. When there's no change in y, that gives you what we call a horizontal slope, constant slope. And therefore, the slope is constant, which is a 0 slope, and it's just horizontal line. Okay? And then there's one other type of slope you can have. You'll notice you can put the 0 in the top. 0 divided by a number is 0. When you get a 0 slope, it's horizontal. But another thing you could do, what happens if the x's don't change? Okay? If the x's don't change, then you have to divide by 0. That's a problem in math because you're not allowed to divide by 0. So when the denominator is 0, you end up getting what we call a slope that is undefined, which means it's going to be a vertical line slope. All you're changing is in the y direction, but there'll be no changing in the x direction. That makes it a vertical line. Does that make sense? So there's 3, but remember, you always read a graph from left to right. Well, major concepts here as we move on. Well, let's do a problem here. First one, find the slope of these 2 points. Again, just practice. Anytime you got 2 points, you can find the slope. Slope is equal to, by formula that you have memorized, y2 minus y1 over x2 minus x1. That's going to be equal to, look at your numbers, 5 minus negative 2 divided by 4 minus 3. A minus makes it a plus. So that gives me 7 divided by 4 minus 3 is 1, which gives me a slope of 7. What does that tell you? What's the slope of 7 going to mean? It's going to be increasing. 7 is positive, and the bigger the number, the steeper it's going to go. So this is going to be kind of a wee bit steep slope here, but it's most important as you read it from left to right, it'll be going up. It's increasing. Yeah.
When you got the 7/1,
Yeah.
you could use that to actually plot the points on the graph. Is that correct?
Sure. So when you do the rise of run, if you needed to graph the line, that's exactly what we would do.
Up 7.
Up 7 and the right 1. Okay, and we'll get into that when we start doing the lines. Right now, focus on the slope. All right, and again, this is review in terms of the slope stuff. We know you've seen it before, but here's some more concepts here. And it's the difference between what we call parallel lines and perpendicular lines. Two lines are parallel if and only if they have the same slope. So when we talk about this, two lines, y1 equals m1x plus b1, and the second line, y2 equals m2x plus b2. If the slopes are equal to each other, if m1 equals m2, but yet the b's are different, what you're going to do is this. You get two different y-intercepts, but they got to be going in the same direction. The slope is that direction. They're either both going to increase the same amount or decrease the same amount. So if you increase the same amount, they go up the same amount, or if they decrease the same amount, they go down the same amount, which creates parallel lines. Okay? Now, perpendicular lines. You got two lines here, and y1 equals m1x plus b1, and y2 equals m2x plus b2. Two lines are perpendicular if one slope is equal to negative 1 over the other slope. We call that negative reciprocals. That's a fancy term for it. But a negative reciprocal is this. If you happen to have a slope of one line to be 2, what's the negative reciprocal? You make it a fraction, 2 over 1. The negative reciprocal is you flip the fraction and change the sign. So what is the negative reciprocal of 2? Negative 1/2. What about 2/3? What's the negative reciprocal of 2/3? Negative 3/2. What's the negative reciprocal of negative 5? Positive 1/5. You make negative 5, make it a fraction, negative 5 over 1. You flip the fraction, 1 over negative 5, and then change the sign. Or throw an extra negative in front of it. Negative makes it positive, which makes it positive 1/5. What is the negative reciprocal of 0? Nope. Undefined. What's the opposite or perpendicular to 0? Well, if you happen to have a 0 slope, what kind of slope do you have? Well, what kind of line do you have? Horizontal line. What's perpendicular to a horizontal line? It's a trick question. Vertical line. And what's the slope of a vertical line? Undefined. So if you have a slope of 0, you want perpendicular, you get undefined. If you have an undefined slope, you want perpendicular, you make it a 0 slope. So those are kind of special cases there. But usually we do the negative reciprocal on standard slope stuff. Basically negative reciprocal. Take the fraction, that's the slope, flip it, and change the sign. Okay? All right. Now this guy right here. Getting used to formulas. You guys are engineers. And in being engineers, one of the things that we typically do from a math perspective to make our world a nicer place to be is always put certain style of equations in a particular order so we can quote unquote read off data. We do that a lot when we come to things like lines for one, quadratics for another. Let me give you an example here. Okay? Now on this one, it's pretty straightforward. Find the slope of f of x if it is parallel to g of x, which is 3x plus 2. Well, the first thing you're going to have to do is look at this line right here. Recognize it's a line because what is the exponent on the x? 1. Okay? It's actually in this y equals mx plus b format, but sometimes they mix this stuff up. So solve it for y, and if you get y equals some constant times x plus another constant, that's the equation of a line. And the coefficient in front of the x is actually the slope. This is a formula called the Slope-Intercept Form. Okay? And the goal is to be able to read off the data. What's the slope of the line? 3. Okay? And so, continue on with the question though. So if we wanted to have a parallel slope, what does my slope have to be for the line to be parallel? 3. Parallel lines have the same slope. Does that make sense? But this idea that I'm trying to go after here is once a particular equation is in a proper form, you can read off data. You guys used to do this with the old quadratics. You remember? 3x squared plus 2x plus 1. You know, if I said, set that sucker equal to 0 and solve for x, the thing doesn't factor. 3x squared plus 2x plus 1 doesn't factor. So if it doesn't factor, what technique do you use to be able to solve a quadratic that doesn't factor? Quadratic formula. What was the quadratic formula? All right, sing along if you know it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You've seen this before. You will beat this thing to death. I mean, even though it's something you've done years ago, there's certain equations out there that still follow this pattern. We have a whole branch of equations called differential equations. Second order constant coefficient differential equations look like quadratics. So you treat them like quadratics and you solve them like quadratics. How do you solve a quadratic? Well, you got the formula x equals negative b plus or minus square root of b squared minus 4ac all over 2a, but you got to figure out what's a, what's b, what's c. That's reading off stuff off the formula. A is the coefficient in front of the x squared. That would have been the 3. B is the coefficient in front of the x. That would have been the 2. C is the constant term. That would have been a 1. And those are the numbers I plug into my formula to be able to get the answer. That's classic engineering math, okay? Reading off data out of forms. Look at this guy down here. Find the slope of h of x equal if it is perpendicular to g of x. Well, g of x is equal to x over 2 plus 4. This g of x is a line. It's clearly in the y equals mx plus b slope-intercept form. What is the slope of this particular line? 1/2 is the understood coefficient in front of the x, which is 1/2. What does that make my perpendicular slope? Now, the international symbol for perpendicular is an upside down T. The international symbol for parallel is 2 lines that are parallel or upside down. All right, so what's the perpendicular slope going to be? Very good. Flip the fraction, change the sign. Does that make sense? All right. But that just gets us into the concept of lines. Now, let me explain why lines are so important before we jump on this stuff. You know, my goal here, all this stuff in Chapter 1 and honestly Chapter 2 is a little bit of review, but depending on your background, whether you've seen it before or not, you know, or how long it's been since you've seen it, is questionable. So, now, like I said, lines are hugely important because where we're going with this stuff is we're going after the derivative. I'll go ahead and tell you what the definition, the geometric representation of the derivative is. It's something called the slope of the tangent line. Now let's talk about those words for just a second. Slope of a tangent line. What do we mean by a tangent line? All right, so if you got some weird curve out there in space and you pick out a point, at that particular point, the tangent line is a line that comes in and hits the graph at just that one point, only intersects that one point, and then moves off. And lots of things in physics follow this pattern. Case in point, you're driving, you're over at Lowe's Motor Speedway, you're in your car and you're spinning around and going around a racetrack, 120 miles an hour, 150 miles an hour, 180 miles an hour. Welcome to NASCAR. Okay, 180 miles an hour, right? Going around the track. Okay. When you're in that curve, when you're banking around that curve, you have to hold that steering wheel and pull it in. Just regular driving works the same way. You got to hold that thing in. What happens if you let the steering wheel go or something breaks in your car and your steering goes? Well, you go straight into a wall. What path do you take? You take the tangent line path. You no longer stay in the curve. You will go in a straight line, eventually into the wall. Otherwise, you go into the stands and kill lots of people. But you go into a straight line, right? But the path that you take is the tangent line path. And so to figure out that path that you're taking, this comes into the part of playing around with these derivative concepts. Because it's a line that you would have taken here, same idea. You guys played with slingshots before when you were kids, right? All right. So in the old-fashioned, David and the Goliath style slingshot, the two little leather pieces, and you hold this rock down here in a little leather pouch here, and you swing that sucker around, okay? Well, one of two things is going to happen. You swing that sucker around, and you let it go. Well, if you let it go in the wrong spot, what happens? It hits you in the head. But if you let it go just right, that sucker flies off in what path? Because you spin it like this, and the moment you release it, the appropriate moment you release, it will take off in the tangent line path, okay? At that same velocity that it was being spun around, and that's how you can kill Goliath, that type of idea. Does this make sense? These tangent line paths are very important, but the tangent line paths are lines. That's why we're beating you guys to death on this line stuff again. I know again is the key word here, because I know you've seen this stuff before. But here's the deal. Depending on your background, and I can tell you right now, most teachers don't teach it the way I teach it. Why? I don't know. I just think they should take my class and actually learn this stuff. But let me explain why this is important. All right, first off, you got the slope. We just went over that. The standard formula for slope is, rise over run, changing y over changing x, or the formula is y2 minus y1 over x2 minus x1. There are 5 formulas for lines. And they got names. You've seen these guys before. There is the famous slope-intercept form, the famous y equals mx plus b, right? The next one is the formula called the point slope formula. Y minus y0 equals m times x minus x0. There's the famous general form, a times x plus b times y plus c is equal to 0. And there's the little known horizontal line. You just get y equals some number, b is a constant. Y equals 4, that's just a horizontal line. If you have a vertical line, there's a special case here. X equals 2, that's the equation of a vertical line. X equals a constant. Okay? But there are officially 5 forms of lines. And here is the sad thing. Okay? Out of all these forms of lines, which one's the most important? The most important, aka my definition, but most important, which one do you use the most? All right, that's exactly right. Your teachers never taught you, they taught you every one of these forms, but they never taught you the purpose of these forms. Okay? Now, the slope-intercept form is important, but it's actually the second most important line. When do I use the slope-intercept form? You use it for 2 things. I'm going to write them down here for you. You use this guy for 2 reasons. You use it to, quote unquote, read off data. Remember the last problem we just did? Y equals 3x plus 2. What's the slope? What's the y-intercept? You read off data. That's why you want that y equals mx plus b form. First purpose is to read off data. Second purpose, when do I use y equals mx plus b? You use it to graph. To graph. Y equals 3x plus 2. The y-intercept is 2. I put that dot on there. What was that slope? 3. We would write it as 3 over 1, and then get to the next point. I start at 2. I rise 3 units. I run 1 unit, put another dot, and then I can do it as many times as I need to until I get the pattern for the line, and then I connect my dots. It's used to graph, right? Those are important. Don't get me wrong. Those are very important, but it's not the most important. The most important equation of a line is the one that nobody ever remembers. No, it's not the general form. No, general form is kind of lame. Okay, the general form is actually just to make things look good. I'll write this down. Don't worry about it. The most important form is the slope form, point slope form. This is the number 1, right? And you know when to use the point slope formula? When you see these words right here, it only has one purpose in life. Find the equation of the line. Anytime you hear those magic words, find the equation of a line, which 99.9% of the problems you're ever going to encounter with lines is going to start off, find the equation of a line that, and they give you a bunch of stuff, right? You start with the point slope formula. And that's the one nobody remembers. So if I ask you a question, find the equation of a line that does something or other, most people screw it up because they don't know where to start. And you start with this formula right here, point slope. You know, our textbook, y minus y0 equals m times x minus x0. The book that I used to use in high school was y minus y1 equals m times x minus x1. You got a point. I mean, when do I use this point slope form? Well, it's pretty obvious. You use the point slope form when you have 1, a point, and 2, a slope. This is how you use it. We're math people. Don't think too deep in how we come up with names and stuff. It's called the point slope form because you need a point and a slope to use this guy. Okay? All right. The least used one is the general form. ax plus by plus c equals 0. But now, to understand this material, everything has a purpose and why we do it. General form has one purpose in life. What is the purpose of the general form? ax plus by plus c equals 0. This is the purpose in life. That's it. It looks good. If you put all the variables and constants on one side and set it equal to 0, that looks pretty. It's great for publishing. If you're writing a textbook, this is awesome. 3x plus 2y equals 7, 3x plus 2y minus 7 equals 0. Looks good on pulling all the variables on one side with the constant and setting equals 0. It has no real purpose in life whatsoever. You don't do anything with it except it just looks good. But it's a particular type of form. Usually when we have this general form, a, b, and c are going to be integers, plus or minus the whole numbers. And typically, we want to pull it to the one side where the a, the coefficient from the x, is positive. That looks real good to make the first coefficient positive. 3x minus 2y plus 7 equals 0. 5x plus 7y plus 1 equals 0. Pulling all on one side, and you make sure a, b, and c are nice big positive. Or no, a, b, and c are integers, and especially a has to be a positive integer. It just looks good, though. We don't do anything with it. These two guys, the slope-intercept form and the point slope form, we do something with. And the sad thing is, the most important form is the one that nobody remembers, because this is the guy you would start every, 99% of every line problem. Find the equation of line. This is the form that you use. Okay. These are two special cases. The horizontal line, that's a special case, y equals b. Vertical line, x equals a constant. These are special cases because, this one has 0 slope, this one has no non-existent slope, does not exist, undefined slope. All right. You see this guy right here? Number 1. Write the equation 6x minus 9y minus 18 equals 0 in slope-intercept form. First off, I want you guys to notice this. What form is this line, equation of line in? This is general form. Doesn't it look awesome? You've got the 6x and minus the 9y minus 18, and you got all on one side set equals 0. But the fact is, here's my problem. Because what we're going to ask you to do, now listen up, I'm going to tell you where people screw this stuff up at. Careless error kills in this class. All right, I give them this equation on a test. 6x minus 9y minus 18 equals 0. I ask you what is the slope. You know what people are going to tell me the slope is? Clearly 6. Why? Because it's coefficient by the x. And that's wrong. To be able to get the slope, you have to put it in the right form first. Welcome to Engineering 101 from a math perspective. You got to write the right form to be able to read off the data. And what form is it when you want to read off data? Slope-intercept form. And the slope-intercept form is that y equals mx plus b. You got to solve this circle for y. How are you going to solve this thing for y? What's the first move? I'm going to subtract 6x from both sides and add 18 to both sides at the same time, right? Get my y by himself. So this will cancel and this will cancel. That'll give me negative 9y equals negative 6x plus 18. What's your next move? Divide by negative 9. Remember your math. Basic algebra skills. What I do to one side, I do to the other. What I do to one term, I do to all terms. Remember that. What I do to one term, I do to all terms. There are three terms here. Terms are separated by adding and subtracting. So I'm going to divide by -9. So what I do to one side, I do to the other. And what I do to one term, I'm going to do to all terms. Cleaning this guy up, clearly the -9's cancel, and that solves it for y. Y equals, now let's reduce all fractions here. What is -6 divided by 9? Well, negative divided by negative is a positive. 6 divided by 9 is also known as 2/3. 2/3 x. What is a -18 divided by, screw that up. What's a positive 18 divided by a -9?
-2.
-2. And now, for purposes, I now want you to answer the question. What is the slope and what is the y-intercept? What's my slope? What's my y-intercept? Sign goes with it. -2. Does that make sense? Don't lose you guys anywhere. But you notice what I did. And I'm telling you, I had too many students in my past that are looking for that quick answer. I give you this form of a line, 6x minus 9y minus 18 equals 0. Ask them what the slope is. And I'm telling you, third class tells me it's 6. Because they're so used to, you're right, it's the coefficient in front of the x. Wrong form, dude. That's general form. Not the right form. It's got to be in slope-intercept form. Then the coefficient in front of the x will be the slope. Does that make sense? Notice your forms. And the other thing is, while you're at it, just for practice, I want you to graph it. What is your y-intercept? -2. -1, -2. Throw some hash marks on this thing just to make it look good. And when you're graphing, always label the x-axis, always label the y-axis. Okay, y-intercept is -2. That's what that B stands for. What's your slope? 2/3. It's positive, so it means to get the line out of it, you start at your y-intercept because you got your 1 point. To get to the next point, I'm going to rise to 1, 2, and I'm going to run 3. 1, 2, 3. And then I'm going to put my dot. Does that make sense? I got a question for you. How many points do you need to have an equation of a line? Well, there can be, on a line, there's an infinite number of points, but really to get the picture of a line, all you really need is 2. There's my 2 points, and all I got to do now is just connect my dots. 6x minus 9y minus 18 equals 0 is this line. This line is also y equals 2/3 x minus 2. Does that make sense? Okay. Question? Yes, sir.
Can you go from slope-intercept to point slope?
Can you go from slope-intercept to point slope? No. Well, you can, but who cares? Let me explain that. There's no reason to do that. Look, okay, let's go back over here for a second. Look at this point slope form. And I changed it to, because I'm going to say it the wrong, I typed it like the book, y minus y0 equals m times x minus x0. But the way I learned it was always y minus y1 equals m times x minus x1. So I know I'm going to say the one thing here, so I always go ahead and write it like that. But here's the deal. You see this line right here, the point slope form? It's what you use when you hear the words find the equation of a line. This gives you a line, find the equation of a line. However, here's your problem with the point slope form. It is not a pretty equation. Y minus y1 equals m times x minus x1. This is not the form we like to leave them in. We like to leave them in the famous slope-intercept form so we can eventually graph it or read off data. Or we also like to leave them in general form because it just looks good to slap everything on one side. Okay? So we don't leave answers in point slope form. That's where we start with the answer, and then we'll polish it up later. So let's take a look at this guy and read the first 5 words, please. Find the equation of the line. 6 words. Okay, good. Even better. First 6 words. Find the equation of the line. And right here, you're supposed to find the equation of a line that passes through the point 0, -3 with slope -2. Okay? Right here is where students die because they don't know what to do. Okay, they start fiddling around and guessing and stuff like that. No. This is, again, this is being methodical. I'm setting you guys up because before too long, instead of finding the equation of a line, you'll be finding the equation of the tangent line. Same process, except for the calculus that's going to be involved when I teach you guys that stuff. So here's the deal. Find the equation of line. Anytime you hear the words find the equation of line, where are you going to start? Point slope. What is the point slope formula? Y minus y1 equals m times x minus x1. What two things you need to be able to use the point slope formula? Remember, we're math people, don't think too deep. Point and a slope. What did they give me? They gave me a point, 0, -3, and this is my point, so this is your x1, y1. And they also gave me the slope. What's that? Oh, they gave me exactly what I needed to use the point slope formula. All you got to do is plug it in. Remember, on the point slope formula, m is clearly the slope. The variables with the subscripts are my points. The variables without my subscripts are standard variables. Leave those guys alone. So, y minus y1 is -3. What's the wonderful use of parentheses is I'm literally plugging it into this formula. Equals my slope, which is -2, times x minus x1, and my x1 is 0. Does that make sense? Did I lose you anywhere? Well, there's your answer. It's just as ugly looking equation. So, what we're going to typically do is ask you to and put the answer in slope-intercept form or general form, because that's the two forms we typically put the answers in. Let's put this one in slope-intercept form. So if I wanted slope-intercept form, what's the big deal about slope-intercept form? It's y equals. All you got to do is solve this thing for y and you get the answer. Okay? It's the y equals mx plus b, but the trick is just solve for y. So I would clean this guy up. So this would be y plus 3 is equal to -2x minus 0. Who cares about that? That just drops off. And then to solve for y, what am I going to do? Subtract 3 from both sides, and I get y equals -2x, minus 3. Does that make sense? I lose you guys anywhere. Okay? Oh, I'm sorry. Screwed up. Part B, Part A. Part B, I want it in general form. General form. How do I put y equals -2x minus, that's minus there, minus 3 in general form? What? I'm going to set equals 0, but I told you guys the trick. You want to make sure the coefficients in front of all the variables are integers, plus or minus whole numbers. And I always want to pull everybody to the side, because you're going to set equal to 0, that makes the x positive. You'll notice the coefficient in front of the y is 1, the coefficient in front of the x is -2, the coefficient of the constant is -3. So everybody's already an integer, plus or minus whole number here, right? I'm just going to pull it all to one side to make it to proper form. So what side am I going to pull it to? I'm going to pull it to the left side so I can make the -2x, when I pull it to the left, make it positive. So as y equals -2x minus 3, I would add 2x to both sides. And I would add 3 to both sides. And that kills off everything there. So the answer would have been in general form, 2x plus y, because that's just one y, plus 3 equals 0. This would have been the appropriate answer in general form. And what purpose in life does the general form have? It just looks good, having everybody on one side. That's it. Does that make sense? All right, take a look at this next guy. Find the equation of a line that passes through the point 3, -2, and 4, 5. What's the first 6 words? You are being programmed personally by me, and this is why you guys should be able to make an A in this class. When you hear the words, find the equation of a line, you know what form you're going to use. What form is that? Point slope. Y minus y1 equals m times x minus x1. But be able to use the point slope formula, what do you gotta have? Point and a slope. What do we got? We got 2 points. Well, I got the point covered. I got way more than enough points. All I need is 1 point. I got 2 of them. But the thing I don't have is the slope. So I'm gonna have to start there. To get the point slope formula, you need a point and a slope. I got 2 points, got the point part covered. I need a slope. Remember your slope formula, m equals y2 minus y1 over x2 minus x1. And I'm gonna call this guy my first point, my second point here. So y2 would be 5 minus y1 would be -2, and watch your signs, because it's just a little losing of a sign someplace means you have to take this class over again. Don't screw up, okay? So 5 minus -2 divided by x2, which is 4, minus x1, which is 3. A minus is a positive. That's a 7 over 1, which makes my slope 7. Does that make sense? So now I've got my slope. The slope is 7. Now I need a point. I got the point 3, -2, and 4, 5. Which point do I use? Honestly, it doesn't matter. Personally, I use 3, -2. Yeah. Smaller numbers, less chance for me to screw this up. Negative. Does that scare you? Well, 4, 5, and 5, 4 scares me if I'm dyslexic. But honestly, it doesn't matter which point you use, you'll get the same answer. However, I am of the adage that I would use these smaller numbers because less chance for me to screw the numbers up. All right? And I want to let you guys know something or other. And I tell every one of my students, whether I'm teaching grad students, undergrad students, I work with gifted and talented high school math programs all throughout the state and stuff, and I tell everybody the same thing when I'm working these kind of problems. Look, we work this stuff together. Everybody makes careless errors. Nobody's perfect in this world, okay? We have some very famous mathematicians in our math department at UNC Charlotte. And I'm telling you, I've seen these people screw up stuff like you wouldn't believe. It's incredible. Everybody screws stuff up. Whether you're famous or not famous, it doesn't matter. The difference between me doing this stuff and you guys doing this stuff is one very simple rule. I've graduated. They're not going to take away my doctorate degree because I can't add 2 plus 3. They probably should, but they won't actually, because once you graduate, it's yours forever. All right, so we work this stuff together. We all make careless errors, okay? So work this stuff together and just plug in the numbers. So I'm going to use this one because the numbers are smaller. So y minus the y coordinate, which is -2, equals my slope, which is calculated with 7, times x minus x1, which would be 3. Again, this is the answer. The problem with this answer is, in point slope form, it doesn't look real good. So, and I'm going to let you know, probably about 75% of the questions I ask you guys, I'm going to put it in the slope-intercept form, because then we'll probably graph it or do something or other with it. So let's just get practicing on putting it in slope-intercept form. But don't forget to know how to put it in general form as well. So I'm going to first clean it up. A minus is a plus. That's y plus 2. And I'm going to distribute the 7. 7x minus 21. And I'm going to subtract 2 from both sides to solve for y. And I got y equals 7x minus 23. And there's my solution. The slope is 7. The actual y-intercept is negative. Sign goes with it. Negative 23. Does that make sense? All right. But my point to all this is this. Now, I know every one of you guys have covered this kind of stuff before. But did your teachers actually rank these things and tell you which one was the most important, when to use which form and stuff like that? Right, and again, because you got options, but they never were clear and concise on which option should go with which case, that's when people screw this stuff up. And it actually is very simple. Pretty much, anytime you hear the words find the equation of a line, use point slope form. When slope-intercept form, which is the one everybody remembers, y equals mx plus b, actually has 2 important purposes, but only 2 purposes in life. Read off data and be able to graph. And the general form, the ax plus by plus c, and we put in that form just to make it look good. There's no real purpose to put it in this form. You don't really do anything with it. And then, of course, the special cases of the horizontal line, y equals a number, or the vertical line, x equals a number. All right, same page. All right, let's practice some more. Find the equation of a line that passes through the point 0, 0, can't beat that one at stick, and is parallel to the line y equals 3x minus 9. Now, some of these problems I stole off of WebWork, so excuse me for points like 0, 0, but that's what WebWork gave me, so we would do it. Find the equation of a line that passes through the origin, all right, 0, 0, and is parallel to the line y equals 3x minus 9. What are those first 6 words? And therefore, what form am I going to use? Point slope. Y minus y1 equals m times x minus x1. If you ever use the point slope form, you got to have 2 things, point and slope. What's that? Point, 0, 0. Got the point part covered. What's the slope? Now they're starting to put some curves at this curve ball, basic baseball here. They didn't give me the slope, but they gave me something similar to the slope. They gave me something called parallel. Parallel lines, noting some data here, parallel lines have what? Same slope. So I got the line y equals 3x plus 2. In slope-intercept form, y equals 3x minus 9. What is my slope? 3. Hence, what would my parallel slope be? 3, because parallel lines have the same slope. So there's my slope. There's my point. Plug it in. Y minus 0 equals the slope of 3 times x minus 0. Solving it for y because that's about as easy as I can make it. What's the answer? 5 is 3x. Second part, question number 5 here. Find the equation of a line that passes through the point 2, -4, and is perpendicular to the line y equals 1/2 x plus 3. There it is again. It's really putting it in your face. Find the equation of a line. I'm telling you. Most problems about lines that we're going to ask you, we're going to start out with the question, find the equation of a line that does something or other. So these are, word problems-ish type thing here. And again, with most word problems, the hardest part for most people, for most students, is where do I start? Okay, so I'm trying to show you some patterns, and I will continue with this type of pattern all throughout this course. So, find the equation of a line, point slope, and write it down. I'm trying to drum in your memory these formulas. Y minus y1 equals m times x minus x1. All right, I got my point, 2, -4. Got that part covered. And now I need the slope. Well, they put the line, this was awfully nice of them. Y equals 1/2 x plus 3. That's y equals mx plus b form. So I can read off the slope here. The slope is equal to what? 1/2. But they wanted perpendicular. What would the perpendicular slope be? Flip the fraction, change the sign. Negative reciprocal. Does that make sense? The negative reciprocal of 1/2 is -2. Plugging it in, y minus the y coordinate, which watch your signs, is -4, equals my slope of -2 times x minus the x coordinate, which is 2. Again, notice every time I plug in a negative number in one of these guys, I always put parentheses around it, trying to remind myself I'm taking my time. Again, where most students will make mistakes in this class, it's not understanding the material, it's basic careless error. You go through this stuff so quick, you're trying to get the answer in 10 seconds or less, and then you'll screw it up. Take your time. The goal is to pass the class. Not just pass the class, make me look good. Make an A. All right, so there's my answer. Now, I want you to put this answer in both slope-intercept form and general form. Good practice. So I'm going to first solve for y. First, I'm going to clean it up. Y plus 4 equals, and here I'm going to distribute, -2x, what? Plus 4. -2 times -2 is plus 4. I'm going to subtract 4 from both sides. And WebWork really likes me. Y equals what? -2x. This is in slope-intercept form. Slope is -2. What's my y-intercept? Understood to be 0. Plus 0, we just don't write plus 0. There you go. Now, I want you to put it in general form. What would general form be? Good. You want to make sure the coefficient of the x term is positive. So you always move it whatever direction you need to move it to get the x to be positive. Well, it's negative on the right here, so I'll move it to the left. I'm going to add 2x to both sides. And I get 2x plus y equals 0. That's what it would look like in general form. Does that make sense?
Still considered general form or the other way? Zero usually falls off the left.
What do you mean? 0 equals what? See, it's the same equation if I tell you that negative 2x minus y equals 0, but officially, by strict definitions, that's not general form because the coefficient from the x was negative.
It was a positive 2x.
Now, 2x plus y equals 0, well, you know, whether you write x equals 2 or 2 equals x, it's the same thing. So if you put the 0 on the other side, 0 equals 2x plus y, yeah, that's the same thing. All right, what about this guy here? So, what, 90-some% of the problems I've done so far has been using the point slope formula. What about this guy? Find the slope in y-intercept of 3x minus, 9x minus 3y minus 3 equals 0. What about this guy? Very good. What you're doing here is you got it in general form. They didn't ask you to find the equation of line, so I don't need that point slope formula. But if I want to figure out the slope in y-intercept, clearly what form am I going to put it in? Slope-intercept form. Y equals mx plus b. So I've got 9x minus 3y minus 3 equals 0. What's your first move?
Find out the slope is on.
Well, find the slope, but how would I find the slope? My first real move is to turn into y equals mx plus b. How would you do that?
Move everything.
All right, solve for y. I would subtract 9x from both sides, and I would also at the same time add 3 to both sides, right? Trying to get the y term by himself. This would give me negative 3y equals negative 9x plus 3. What's your next move? Divide by negative 3 to get solved for y. But what I do to one side, I do to the other. What I do to one term, I do to all terms. The coefficient in front of the y cancels. You're left with y equals, what is negative 9 divided by negative 3? Positive 3x. What is 3 divided by negative 3? Negative 1, so there's my line. Now, please tell me, what is my slope? What is my y-intercept known as b? What's the slope? 3. What's the y-intercept? Sign goes with it, negative 1. All right, put it all together. This is typically the type of equation I'm going to throw at you guys. Make sure you guys understand every aspect of this stuff. Find the equation of a line that passes through the point 2, negative 4, and is parallel to 6x minus 2y minus 14 equals 0. What's the first 5 words? This is where you start. First 6 words. Find the equation of a line. Point slope. That's where you start a problem like this. Y minus y1 equals m times x minus x prime. To use the point slope formula, you got to have 2 things. You've got to have a point. Well, we got the point part down. They gave me 2, negative 4. The second part is you've got to have a slope. Well, I know I'm going to have, because it says parallel, I need to have the same slope as the slope of this line. 6x minus 2y minus 14 equals 0. What's the slope of this line? Good. No, it is not 6. I'm going to have to kill you. All right. So, why is it not 6? Why is the answer not 6? It's not the right format. That is the most common mistakes my students make. You can't just read off the coefficient in front of the x until you put it in slope-intercept form. Solve this thing for y. I'm going to subtract 6x from both sides, and I'm going to add 14 to both sides. This cancels. I'm left with negative 2y equals negative 6x plus 14. Now what am I going to do? Divide by negative 2. What I do to one side, I do the other. What I do to one term, I do to all terms. Y equals, what's negative 6 divided by negative 2? Positive 3x. And what is a 14 divided by negative 2? 9 minus 7. So now I ask you the question, what's the slope of this line over here they gave me? 3. And hence, by definition, what would the parallel slope be? 3, because parallel lines have the same slope. So now I have my slope of 3 and my point. So now I'm going to plug in my point slope into my point slope formula. Y minus negative 4 equals the slope of 3 times x minus 2. And let's put this thing in slope-intercept form, because clearly we need practice for that, because you need to read those slopes. So let's put this thing in slope-intercept form. So minus and minus is a plus, so I get y plus 4 equals 3x minus 6. And then subtract 4 from both sides, and you get the answer. Y equals 3x minus 10. And there is my solution. Does that make sense? There's a huge pattern for this stuff, so remember that. But you guys don't get to learn this stuff until you start practicing it. Now, question for you before we move on to our next section, section 2.3. First off, you got a question. Yes, sir. One or two pages, yeah. Yes, we are. But so you see, I will remind you that chapter 1 and chapter 2 are review stuff. I'm going to hit you harder by taking what we've learned in class, or more, again, the way I'm trying to approach this is what I'm trying to remind you of what you used to do as review. Because have you done lines before? Yes. No, thank you. Okay. I'm just trying to remind you of what you've done before. Where the payoff is going to be is, number one, I'm going to hit you some very interesting questions on web work, okay? And then, of course, I'm going to give you guys one big homework set when I finish up chapter 2 on chapter 1 and 2 just before our test. That's going to give you the kind of the in-depth stuff that I want, okay? Because, again, as you saw in my lecture today, I am trying to tell the reason why we do stuff is for purposes. The purposes of lines is eventually we're going to go for this equation of a tangent line. When I get to the calculus, which is my focus, not the algebra. Algebra, we're just doing review. But I got to make sure everybody's moving at the same place. I've got 75 students in here. I got 75 different backgrounds. I got to make sure everybody's, for some people in here, I'm boring you to death. For other people in here, people are going, oh my God, I don't remember this. I know I've seen this before, but it's been so long. I've got to get everybody on the same page before I can do the calculus. My goal is to make sure everybody is successful with the calculus. All right. So yes, we are getting more in depth on this stuff, and you'll see that when you see those web work problems. All right. And my big homework set that I'm going to give you guys. All right. Let's move on to another concept here. We're going to be doing what we call standard equations of conic sections. And we're going to first start out with the famous equation of a circle. Okay? The equation of a circle is actually based upon the distance formula. And this is the general formula for the equation, or standard form of the equation of a circle, which is x minus h squared plus y minus k squared equals r squared. Okay? Now, let me just describe this to you guys so you guys would understand this. All right. Let's just, in general, draw ourselves a circle. There it is. Okay, yeah, I'm drawing it freestyle by hand, so give me a break. But, yeah, pretty much just a circle, right? What defines a circle? What makes this circle, as ugly as it is, so darn special? What are basically, there are two things you need to know about a circle to make any circle. What are the two things? All right. Okay, so there's two things. You mentioned two things. You need to know, first off, a radius and a center. All right, you first need to know the center. Where are you centering this thing at? The standard symbol for center is the famous HK. Okay? You go over H, up K, and there you go. What defines a circle is a relation that is equal distance all the way around from the points on the circle to the center of the circle. Does that make sense? And the distance from the center of the circle to the outside edge is called the radius. And if I take this radius and move the distance in 360-degree aspect, any point that is the distance r away from that center, it will be making up a circle. Okay? So, what's that now? Well, they're important. Wait. Okay. All right. Find the equation, you're in trouble now, of the circle, so now I'm doing not the line, of a circle whose center is 3, -2, and radius is 5. I want you to find the equation of the circle whose center is 3, -2, and whose radius is 5. I'll draw them for you if you like. Sure, there we go. And here. Put them up here. X, Y. 3, 1, 2, 3. -2, 1, 2, -2. So here's the center. And what is my radius? 5. How do I draw a circle with radius 5? Well, my radius is 5, so I'm going to take my center and move. I'm going to go right, left, up, and down, also known as north, south, east, and west. I'm going to go the directions of the compass. I'm going to go east 5. There's 3, 4, 1, 2, 3, 4, 5. So this will be 4, 5, 6, 7, 8. So there's a point right there. Put a little X for that point. I went east. I'm going to go west 5 units. Here's 1, 2, 3, 4, 5. So this will be over here at -2. Right about there. I'm going to go north 5 points. So here's 1, 2, 3, 4, 5. And I'm going to go south 5 points. 1, 2, 3, 4, 5. And this will be, what about, that'll be -7 down here. All right about there. And then it is me drawing it on the thing, but then all I got to do is just connect my dots there and make your circle out of it. That's how you draw it. And sometimes I will say, and graph. So there you go. I graphed it. But I want the equation of a circle. The equation of a circle is this. Again, equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. This is the general form, or what we call standard form, of the equation of a circle. Equation of a circle, you got to have two things. You got to have the center, and you got to have that radius. What's my center? 3, -2. That means my h is going to be 3, and my k is going to be -2. And my radius, that's my r. I'm going to plug it into this thing. But be careful. Watch your signs. So to plug this information in, I get this equation. I get x, it's minus h, but my h is 3. So it'll be x minus 3 squared plus parentheses y minus k, which is -2 squared equals 5 squared. I just want you to see in my formula, I'm just plugging in my information. Standard engineering style approach to mathematics. Knowing forms and plugging the information into this form. Does this make sense? Clean it up. To clean it up, this would be x minus 3 squared plus, what's a negative? That'll be y plus 2 squared equals, and clean up the numbers, what side, 5 squared? 25. This is the equation of that circle. Does that make sense? That's it. Nothing too deep. Don't worry, I can make it harder for you. But this is it. But you got to have the ability to go backwards and forwards. And what I mean by backwards and forwards is this. Look at this question. Find the equation of a circle whose center is 3, -2, and the radius is 5. And graph it, so I graphed it. But once you got the model, you got the information here, all I had to do is plug in 3 for h, k is -2, and plug in for radius 5. Yes, sir. Okay? But this question was, here's some information, find the equation. Look at these guys. Lots of different ways I can ask you about circles. Look at these examples here. Give the center and the radius of the following. So now, I'm not asking you to find the equation, I'm reversing it. I'm giving you the equation, I'm asking now for information. Okay? So for each one of these guys, you got to tell me the center and the radius. X squared plus y squared equals 49. What's the center? Outstanding. 0, 0. What's my radius? 7. Remember, this is r squared. It's going to be 49. That makes r equal to 7. It's x minus h squared. I just got x squared. So there's no h there. Well, if there's no h there, h must have been what? 0. Because how do I subtract, what do I subtract from x to get x itself? You subtract 0. So it's 0, 0. Does that make sense? Look at the next one. X plus 1 squared plus y minus 4 squared equals 25. What is my center? And what is my radius? Radius is 5. What's my center? -1, 4. All right, let me explain. Pay attention to signs. This is the formula. X minus h quantity squared plus y minus k quantity squared is equal to r squared. Okay? So, I've got a minus h. So I just want to show you this. In this particular problem, from the formula, minus h has to be equal to a plus 1. Right? Minus h is equal to a plus 1, and I got x and y minus k squared. I got y minus 4 squared. So the minus k from the formula has got to be equal to a -4. That's really what's going on. Now you got to solve for h and k. So to solve with these negatives in the formula, you just divide by -1. And when I divide by -1, what do I get? I get h to be -1. And I get k to be +4, and that's the -1, 4. But that's the long-winded version on how to do this. What you should remember is this. And these are going to be, a lot of these forms are like this. I got x minus h. When I got minus h, I'm comparing it to a +1. You basically, all you got to do with the minus h in the formula to get what the h's are equal to, you locate it and you take the exact opposite number you see. Because the minus h is telling you to take the opposite. I got +1. What's the opposite of +1? -1. What's the opposite of -4? +4. And that's how you, because it's inside the parentheses, that's how you get the center. You take the quote-unquote opposite. It comes from the pattern of the formula, that minus h minus k. Does that make sense? All right? Give me the answer to number 3. X squared plus y plus 9 quantity squared equals 8. Outstanding. 0, because there's nothing inside my square, that's 0. And I see a +9, so you take the opposite, be -9. So my center is 0, -9. What's my radius? Very good. For the rest of us people, we would have said r squared is equal to 8, so 8 equals the square root of 8. But for you people that are reducing fractions or using interesting calculator stuff, what's the square root of 8? Well, 8 is 4 times 2. Square root of 4 is, we'll pull out a 2, 2 squared 2. I would accept either one of those. So sometimes you don't get nice answers is kind of the point of this. All right. Now, later on, we're going to be trying to mess you guys up because I'm going to be introducing to you guys ellipses, hyperbolas, parabolas, and the like. And right now we're working on circles. What's an ellipse? It's an egg. Okay, I'll give you that one. All right. All right. It's a circle that you flatten one side and it pushed out the other side, right? It's a circle that's been warped. How does that one sound? I'm trying to go for the layman's terminology here. Circle is equal distance. Ellipses are not. All right? You squish it on one side, it pushes out the other. Okay? But they're going to be very similar. The only difference is that equal distance form is going to look like this for a circle. But for an ellipse, it's going to look similar but yet different because they're not going to be equal distance from the center. This one's farther away from the center than the top and bottom are. So because of that, we're going to give you these equations and we'll just ask you, hey, what is this thing? The general form of equation of a circle is x squared plus y squared plus dx, d being a constant, plus ey plus f equals 0. Okay? Now, the problem is this. In this form, it's not in the form where you can read off data. Honestly, what form is this guy? It's kind of like the form of the general, like lines. The general form equation of a line. What was that? ax plus by plus c equals 0. What purpose in life did that hold? It just looked good. You see this guy? This holds no purpose in life to write a circle like this except for one thing. It looks good to have everything on one side. So equals 0. But the problem is, just like in the general form, you can't read off data. Just because it was a coefficient in front of the x in the general form, that doesn't make it the slope. You have to actually put it in the proper form. So the goal to be able to read off data is to take this form and plug it back into the standard form so you can read off that center and that radius, which really defines the circle. Does that make sense? So how do we do that? Well, we're going to be doing something called complete the square. All right, so let me go back and get myself another nice clean sheet of paper here. And please tell me what you guys remember about these words right here. Complete the square. What's that now? You're close. I know what you're going for. How do you complete the square? So first off, let's just remind ourselves. I'm going to give you a general equation here. X squared plus y squared plus 4x minus 16y plus 2 equals 0. This is an equation of a circle. It is in general form. I want you guys to tell me what the center and radius is. Well, to be able to do that, you're going to have to take, okay, so the idea is this. You're going to take this, what was it, x squared plus y squared plus dx plus f, ey plus f equals 0, and you're going to have to turn it into x minus h squared plus y minus k squared equals r squared. This is the idea of turning general form into the form that you can read off the data. Does that make sense? To do that, you're going to do something called complete the squares. To complete the square on a circle, what you're going to do is group x terms together and y terms together and move to other side of the equation. Step one. All right, I got to get my x terms together. You want to group together like terms. X's, x squareds, I want to put those suckers together, plus y's and y squareds, I want to put together and move the constant to the side. So to do that, this is what I'm going to do. All I'm going to do is subtract 2 from both sides. I'm going to move my constant to the other side. Does that make sense? And then I'm going to rewrite order, because a plus b and b plus a are the same thing. So as long as they're together, it doesn't matter what order I put them in. And I'm going to redo them in order. So watch this. This will be x squared plus 4x plus y squared minus 16y equals negative 2. I have grouped together my x terms, plus I grouped together my y terms, and I put on the other side of my equal the constant. I followed my directions in step number 1. Does that make sense? All right. Listen to my words and listen good. Step number 2 is actually the complete the square. Now the purpose of completing the square is, look at these x's and look at these y's. What are they? X squared plus 4x, that's the x's terms. Y squared minus 16y. What are these guys now? They're miniature little quadratics, right? The x squared, or y squared. They're quadratics. What we want to do is we want to factor these quadratics. So we got to add the right number to be able to factor this guy. Now I know you can take out an x, but I'm talking about factor it perfectly. Anti-fold stuff here, okay? So to complete the square, you first got to make sure coefficient of square term is 1. If it is not 1, then divide, okay? But this is an equation of a circle. It's either going to be 1 for both x and y, or you got a constant in front of it, just divide it through and then make them 1. Because for circles, the coefficients of the x squared and y squared will always be the same. For ellipses, they won't be. Okay, we'll get to that later. All right, so make sure the coefficient of the square term is 1, which they are. And then what you do is this. Then take 1/2 the coefficient of the x term, square it, and square it, and add to both sides. Also, take 1/2 the coefficient of y term, square it, and add to both sides. Take 1/2 the coefficient of the x term, square it, and add it to both sides. And take the coefficient of, take 1/2 the coefficient of the y term, square it, and add it to both sides. This is what completes the square. So here we go. Leave a little space here. I got x squared plus 4x, leave a little space, plus y squared minus 16y, leave a little space, equals negative 2. What is the coefficient in front of the x, please? No, that's the coefficient in front of the x squared. I want the coefficient for the x term. 4. Take half of that. So you're going to take 1/2 of 4, and you're going to square it. What's half of 4? Do some math in your head. Squared.
4.
I get 4. And you're going to add that number to both sides. But you see, what I do to one side, I do to the other, makes it a perfectly legal math move. I just completed the squares on the x's. So I added 4. Now, do the same thing on the y terms. What's the coefficient in front of the y?
Negative 16.
-16. Take half of -16, what you get? -8 squared. What's -8 squared? 64. Positive 64. So add that magic number, 64, to both sides. What I do to one side, I do the other. Now watch what happens here. On the x terms, factor. How does x squared plus 4x plus 4 factor? It's x plus 2 times x plus 2. Plus, how does x squared minus 16y, y squared, minus 16y plus 64? How does that factor? Y minus 8, y minus 8. Equals, add them up. What is minus 2 plus 4 plus 64? 66. I can promise you good numbers on this stuff. But notice something rather. When you complete the square, when you factor it, you always get the same term squared. That's what we mean by complete the square. It'll be what we call a perfect square. It is x plus 2 squared. Plus, look at the y's. It is y minus 8, quantity squared, perfect square, equals 66. Now let's see if you learn anything about circles. What is the center, please? -2, positive 8. And what is my radius? Square root of 66. I can factor out as 6, but 6 times 11. Nah, nothing's going to work nice. It's just the square root of 66. Does that make sense? I got it into the form where I can read off data. Complete the square. So, we are going to be getting some depth here, especially if you haven't seen this stuff before. But also, last thing, pay attention to your WebWork site. I've just opened up the next WebWork, as you're still working on the other two, I know, but I've given you some time on this, especially since it's still drop add. But there's now the circle sections up, so you can at least get started on that stuff. And don't forget, we got Friday in here. Zach's going to take over. He's going to show you a bunch of WebWork questions to make sure you guys understand this stuff. See you guys next time. No, ma'am. There's nothing optional about math. It's all required.